This is problem 22. In this problem, we have a velocity versus time graph for the x component and the y component of velocity. And in part A, we want to rank the object's distance from the origin at the letter times. Now, for this problem, I can use the same thing that I did in problem 21 and take the points that I have for the x component and the y component and plot those over here. Only now, because it's velocity versus time, this is going to be Vx, and this is going to be Vy. So this is no longer the path that the object traces out on the floor, so it looks something like this, just like it did in the previous problem. But if I draw the vector, so this is C, and this is E, this vector here is now the velocity at point C. This vector here is the velocity at point E. Somewhere in between, roughly here, that would be the velocity at point D. And then we have the velocity at B and the velocity at A. That's enough to do the ranking. Okay, so if I want to rank the object's speed at the letter time, that's the magnitude of the velocity vector. You could get this from the graph. Just like in problem 21, you could read the numbers off the graph and plug them into this formula here. Or you can rank on what we have here, and that would be A, that's the magnitude, that's the length of the vector, is larger than B. C and E have the same length, and that's greater than D. Okay, let's look at part C next. We want to rank the angle between the object's velocity and the x-axis at the letter times. That angle for A would be like this. For B, it would be from here to here. C, D, E. So the angle's getting larger as we go from A to E. So this is the largest angle. This is the smallest angle. The only tricky thing here is E is either 0 degrees or 360 degrees. If it's 360 or 0, you can call it 360 and make it the largest. And the ranking looks nice if you do that, because then E is the largest, and it goes E, then D, then C, then B, then A. But if you want to say E is 0 degrees, you can make E the smallest. But if it's past 0, so if you have something like this, don't go around more than once like that to do the angle. So the angles should be between 0 and 360, and if it's right here, you can call it 0 or 360, but don't go any larger than 360 for the ranking. Okay, now back to part A, rank the object's distance from the origin at the letter time. Well, we know for model 1, if you have a velocity versus time graph, you can rank on the change in position, but you can't rank on the position. So we are not given enough information here to determine the distance because we don't know where the object started from. So the ranking cannot be determined. We can't find change in position from a velocity versus time graph, but not distance from origin. So depending on how you pick your coordinate system, you could choose the origin to be right at A, or right at B, or right at C, or right at D, or right at E, and that, in each case, you would have a different ranking. That's 22.